Welcome to this new video about Hexabitz. Today we'll learn how to assemble, disassemble, and modify and reuse an array. So how do these modules connect to each other? If you look at the module to the left side of the screen, there are PCB connectors on the edges and sides of the module. Once you put these connectors next to each other and we solder them, then we create physical and electrical connection between the modules. So the ones on the edges are for power. On the top you have 3.3 volt, and on the bottom side you have the ground or zero. The connectors on the sides are for data communication. So they are the serial ports that connect the microcontrollers together and transfer data between these modules. To build these arrays, all I need just to solder these points. They are large enough, so they're easy to solder, and I'll end up with a rigid and reliable board. So now let's see how we can solder these modules together to create an array. I have here three modules: the sound speaker module, the micro SD card, and the Bluetooth module. I'll combine them together to create something similar to an MP3 or like an iPod device, where I can stream files from the micro SD card to the sound speaker, and then I can control the device using Bluetooth from my smartphone or Bluetooth headphone or etc. So let's connect the modules in this configuration. One of the main features of Hexabitz that the modules are modular and symmetric. They can be connected in different configurations, like this one for example, or this one. So I'm all free to connect the modules whichever orientation I want, as long as they all face the same direction, like all up or all down. They can be assembled even in non-flat geometries, like this dome-shaped array, and I can attach modules to it from whatever direction I want. And if I have pentagon module, then I can fit it here as well. So let's start assembling modules in this configuration. All we need to do is just to solder the common connectors between these adjacent modules. Now the array is finished. It looks and functions like a single board. It's rigid, and actually it's ready to be programmed. Now let's say after we use the array for a while, we decided that we want to upgrade the project, like add new functionalities and new modules. It's easy to do that. We don't have to redo the design. All we need just to take the new module, like for example this one. Let's say we want to add an RGB LED module and attach it to the array. Moreover, there are free ports, so we have to solder the new points and then upgrade the software, and that's it. But what if we decided that you want to change the array configuration or shape? Like for example, move one of the modules. like move this one to a different location, to this location for example, or maybe move it somewhere else, or even remove one of the modules and just use 3 of them. We can easily change the array configuration and modify the existing modules. Now we got them separated, so let's clean the residual solder. I'm going to put this module back, but in a different location. So let's see, put it here. And now the modified array is ready. So we all know how fast electronic devices might become obsolete, and then we have to replace them and get newer generations. And we all know about the massive amount of electronic waste that we generate every year. So Hexabitz could help solve some of these problems by enabling us to modify and reuse electronic devices. For example, if this device is not useful anymore after a couple of years, or we can just disassemble and use the modules, reuse them in different design, or just donate them to somebody else who might need them. Thank you for watching this video. The next one will show you a real example and talk a little bit about Hexabitz firmware.